Rolling on my phone. So I'd like to introduce Shane Glass, who's at Google, who's going to give us a presentation today about the public data sets that Google Cloud and that are available through the Google services, including Google Cloud Storage and BigQuery. We talk about how users can use this data, and hopefully I'm also hearing about how we can share other data into this, because I think that's it's the joining of all this data to put all together that I think will advance research and make everything better. Shane is a program manager at Google under the Cloud Developers Relation Group, where he leads the public dataset program. This, as I said, is facilitating high demand public data sets in order to make it easier for researchers to access and uncover new insights and do things that they can't do otherwise. That's really, I think, the point. I've seen several examples of BigQuery in action, and it has a lot of very nice capabilities. Before joining Google, though, Shane was a project manager at NOAA's Big Data Project, and is currently serves as Public Affairs Office to the U.S. Army Reserve, and has received his bachelor's degree from the University of South Carolina and master's from University of Maryland, UC. And I'm looking forward to hearing all the details here. So without further ado, please take it away, Shane.
Yeah, thanks, Niall. I think you really summarized the program nicely of enabling people to do things that they otherwise wouldn't be able to do, or maybe would be able to do, but is like really, really intensive and really labor intensive and probably not worth doing otherwise, just because the amount of prep work goes into it. So I appreciate that intro. As Niall said, my name is Shane Glass. I am the program manager for Google Cloud's public dataset program. I am in Pittsburgh right now, so if you're cold, I understand. If you're not, I'm jealous. So I appreciate everyone dialing in today, and let's go ahead and get started. So here's just kind of a quick overview of the topics for today. Just kind of an overview of the program itself. We'll dive a little bit deeper into BigQuery, the product. And I think Niall touched on it nicely that, BigQuery has some really great capabilities and has some really great potential in kind of serving some of these workloads, especially for structured data, but also can do some cool things with unstructured data as well. And I think that we'll cover that a little bit in the demonstrations here at the end. That'll be a nice teaser to hopefully keep people sticking around until the end. We'll kind of give an overview of some of the public data sets we have in the program, and of course the fun part at the end, the demonstrations. I was telling Carl before everyone joined, I have tried to keep Murphy from attending this presentation, as Murphy's Law of Tech Demos is a well-known phenomenon to me. So most of those are pre-recorded, so hopefully we will do this as smoothly as possible, but I'm sure I'll manage to break my last demo, which is supposed to be live. And Carl's put a note here in the chat, and I want to echo that, if anyone has any questions, feel free to dump them in the chat, and I'll try to pause periodically if anyone has questions that they want to address. So let's start by just going over the program itself, but I want to start with kind of the scientific process, right? And not the 8-step scientific process that we all learn in middle school or in elementary school, but kind of the scientific process as we know it today. And this is kind of what it looks like, right? Like, I don't think this is a crazy off-base way of describing it, in that you have to discover the data set and where to access it. And in my time at NOAA, one of the phenomenon that we continued to hear from users was that in order to use NOAA data, you have to know what data you're looking for and where to look for it. I mean, NOAA does a fantastic job of sharing data that they produce for their mission, but it can be difficult at times to discover it because there's no central catalog for all NOAA data, or even most of the line offices, most of the individual line offices don't kind of have that centralized catalog. But let's say you get past that point, you've discovered your data set, you've discovered where to access it. You need now to be able to access it in a bulk machine readable format. Now, hopefully the Open Data Act, which was recently signed into law, will help with that. It does have a requirement for machine readable data publication, but in the meantime, that can be difficult to find and to access. you have to write a program to parse all of your data into some analysis tool, right? Whatever that is. If it's BigQuery, if it's Excel, which is a perfectly legitimate analysis tool, if it's Tableau, whatever it might be. You then have to load the data into some database using this program you just wrote. You need to manage, you need to update, you need to maintain, you need to secure this data and this database. You need to update your data regularly. And then you probably want to link your data or your research with private data sets, something that you've produced in your lab and are looking to do some kind of unique analysis on. And you now kind of have to go back through this whole process to find these public data sets or these private data sets again and bring them into the same place. You're going through this process twice. And then you need to analyze it, which to me is the fun part. You need to share your data, and then you need to visualize and communicate your results. I like need a cup of coffee after describing this. Like this is a long, kind of complicated process. And I think that part of our goal here in the public data sets program is to alleviate a lot of this burden from the scientist. And I guess my question to you would be, well, what if someone else did these steps? What if someone else discovered the data and where to access it, kept it updated, kept it maintained, and kept it in an easy to link place for public data, and then on the back end kind of helped you share your data? That would sound pretty nice, right? And that would allow you to do the analysis and visualize and communicate your results, which is, I think, the fun stuff, right? That's kind of the get to the fun part. And the crux of this here is that, that's really the purpose of the public data sets program, is to kind of take these steps away from the burden from you. And what we found is that, we have hundreds of users that are doing all of these same steps in parallel and all repeating the same process. And so we at the public data set program kind of take on this process of working directly with providers of data, of onboarding these data sets, bringing them in, keeping them updated, keeping them maintained, making sure they're well described, that they link out to legitimate metadata, that they link out to DOIs, that they link out to source pages for more question, and help people share data so that they can focus on their analysis and so that they can focus on visualizing and communicating their results. We think that this kind of allows you to do a heck of a lot more science. The kind of often thrown out term for how much data prep and data cleaning are you doing is compared to how much analysis you're doing is about 80% data prep to 20% analysis. I think that we can offload some of that 80%. I mean, we're never going to be able to offload all of it because each analysis is going to have unique cleaning steps that's required, and that's okay. But we can offload a significant portion of that and let people refocus some of that 80% of their time, and hopefully maybe shift that paradigm to the 80% analysis and communication and 20% kind of cleaning and prep and finding data. So with that, I've kind of now had two introductions, but I'll give myself a third. So I'm the program manager for the public data sets program. I am about a year in. I came over to Google in April of 2018. So almost a year ago. I previously managed the NOAA Big Data project, working for Ed Kearns over at NOAA, and still work with them pretty closely today as one of our providers. And my background is in data and analytics, and the reason I like to include that here is that the difficulties of finding a data set are very personal to me, and that when I was working on my master's, it took me longer to find a data set that would work for the type of analysis I was doing, was big enough to help me learn how to build these models, and that would give me kind of a full-featured model, but wasn't so deeply complex that I had to be a PhD climatologist or I had to be an expert in that field to really know how to work with the data. So, this kind of challenge of finding and helping people discover public data and helping people share their public data is something that's very personal to me in my background. It's something that I'm very passionate about as a result of that. So this is kind of a high-level mission statement for the public data sets program. And it's a very natural extension of the Google kind of mission of making the world's information discoverable and usable to everybody. And so that's kind of where we come from here of maximizing the availability and accessibility of high demand, high value public data sets through Google Cloud Platform. That's through BigQuery and Google Cloud Storage for unstructured data. And the reason we're doing this is to reduce barriers to entry and to maximize the ability for all users to use data. Last year we kind of ran a little bit of a marketing campaign talking about knowing what your data knows. And I think the basis for that was kind of based on this, this concept that data is the new oil, right? That oil in its kind of raw form has value, but it's really after the refinement, much like data, when you refine that into insights, that's really where that value comes from. And so making it as easy as possible for all users to get right to the refinement step, I think that's really kind of the crux of the value proposition we're finding here. We think this is done best by providing scalable, centralized processes, vetted best practice, cross-functional launch teams, and unified messaging to help bring in everybody and lowering these barrier to entries, whether it's not knowing how to work with NetCDFs or GRIB or HDF files or a lack of subject matter expertise. We're not going to make someone the subject matter in a data set, but if we can explain to them, hey, here's what the shorthand in the column name means, and here's when we say temperature, we mean water temperature here versus air temperature there, and kind of helping reduce some of these barriers to entry, we think we can really unlock some really cool and really exciting new research. So our current catalog has about 115 public data sets. It's a pretty ballpark estimate. We're kind of onboarding more all the time. And so I think last I looked as I was preparing these slides, it was 115. You can see this like fun scattershot of other people's logos that I get to take credit for on these slides. These are logos from data sets that we host. So you'll see some familiar ones on here. If you're really looking keen, you'll see that the Google logo is actually on here. We are hosting a data set that's produced internally, looks at political ad spending in the US from campaigns and committees as part of our kind of effort to increase transparency around the subject. And so these data sets are onboarded and maintained by Googlers with input and guidance from our providers and our partners there. And I think that the value add there is that we're working, our engineers, these Google engineers that are building these world-class search tools, Gmail and G Suite, are also kind of the same experts that are helping us maintain these data sets and maintain these pipelines to bring in these data sets so that our users can be confident that what they're using is the latest and greatest data set from the data provider. So more than 2,000 tables in BigQuery currently available for public use. I kind of got some high-level metrics here on the next slide. So in those 115 tables, roughly 100 data sets in BigQuery, whereas the other 15 are in Google Cloud Storage. About 2,000 tables across them. We have 42 billion rows across those more than 2,000 tables. And this number continually grows every day as we continue to keep data sets updated, some as frequently as hourly. And more than 6 petabytes of data in Google Cloud Storage. So this is primarily things like satellite imagery of looking back down on Earth. But we're also having some really exciting discussions with astronomers, with kind of different subsets and different users around different communities. So there's a great variety of data sets in here that surprisingly can have some like really exciting impacts for our users that often don't kind of expect to see what they're seeing out of these data sets, or when they join it with their personal or private data, are learning something new that they didn't expect to be there in the first place. So I'll kind of give a brief overview of BigQuery. I don't know how much everyone knows about BigQuery. My colleague Carl's on the call, probably knows a good bit, but my colleague Stephen, who's on the call, probably knows a good bit. If not, Stephen, your secret's safe with me, and feel free to take notes here, and no one will ever know. So just kind of a brief overview. So BigQuery is this serverless SQL implementation, and I think serverless is kind of a misused, kind of misnomer in the community right now. It's not that there are no servers behind it. It's that you don't have to manage the servers. You don't have to add servers if you need to get more capacity. You don't have to turn off servers if you have excess capacity. it's that this kind of scales seamlessly with what your needs are. And that's why I kind of say seamlessly scale without the manual management of, if you need to do a multi-petabyte analysis, you can do that in BigQuery. And if you need to do a 5 kilobyte analysis, you can do that in BigQuery. Both will be fast and pretty responsive, and both will kind of scale to meet your demand while only charging for what your actual usage is. So it's a really nice data warehouse and access layer with a really nice clean SQL implementation to either slice data sets, like really huge data sets that can either be locally downloaded or fed into GCP. We've got some great demos on that later of kind of some best practices of doing that I think will be really helpful for the community. One of the other benefits of BigQuery is that it allows you to simply share the data you want, but it's secure enough to protect the data you don't. So these kind of user-defined access control logs and the high availability and redundancy of BigQuery combined with this like very cheap storage and the pay for what you use model, the compute payment model, is a really effective way to distribute data between research teams and also publicly if you're looking for to support publications, if you're looking for reproducibility, but also if you want to share data internally and control who uses that. One of the nice things is that a single copy of the data serves all users. So if all of your users currently have a copy of the same data set downloaded on their personal hard drives right now, you don't have to worry about potentially hundreds of different users or tens of different users were keeping the same data set updated, having to pay for storage for the same data set 10, 20, 30 times, having to say, well, are you using the latest version of this? We'll know that's this version, you need to re-download it. This kind of single centralized copy updates for everybody, and that kind of allows you to more effectively and more quickly share the latest version of the data. And I've touched on this a little bit. It's a pricing model that enables you to focus on science. So really affordable storage, pretty intense free tiers, and usage-based pricing. So 10 gigabytes a month of free storage in BigQuery. Your first terabyte of scanned data is free, and it's $5 a terabyte beyond that. So my opinion is that you get this really great performance for really large data sets. You get integration with a lot of other scientific tools, whether it's Kaggle, whether it's Pandas, Python, R, Tableau, whether it's joining with data sets that are either public or private, but allowing you to kind of focus on that science and not have to worry about the infrastructure and the back end behind it. In fact, I think yesterday we rolled out a really exciting update for BigQuery, the BigQuery sandbox, that kind of locks you into this free tier of BigQuery and helps you be sure that it's designed to help users get started and become familiar with it in a really fast, easy to sign up way. It doesn't require you to put down a credit card. So it keeps you in this free tier of storage and of queries. It does have some other limitations behind it. I think tables are only persistent for kind of 30, 45, 60 days. I don't remember the number off the top of my head, but a really, really nice tool that, my kind of former colleagues in the federal government have told me is something that's really exciting for them, not having to put down a government purchase card for something that, is not necessarily a set price or the same consistent price every month. We've got some really great case studies available on our website that, you're all very intelligent people. You certainly don't need me to read them to you. On kind of the usage of science data for genomics, for chemistry, for climatology, meteorology, economics, patents, kind of so a lot of great content in there. I would encourage you to check some of that out if that's of interest to you. Okay, so that's, I think, a pretty good overview of what BigQuery is. Now, how can BigQuery support open data use? I've kind of grayed out the business one on here. We use this slide to talk to pretty generalized audiences. I don't know that this is particularly applicable to this audience. I'm more than happy to ungrade if I'm wrong. But I think that we work really well with the public data set program specifically works really well with researchers in joining public data from multiple sources with each other or with kind of private internal data to conduct your analysis, and with data providers. We talked earlier about providing that one simple copy, providing read access out to users and allowing them to kind of have this really fast, really simple access without having to scale the on-prem services. What's really nice about this, the challenge we found when I was at NOAA was that the more popular a data set was, the harder it was for NOAA to share that data set. And the reason for that being, if one user wanted a copy of that data set, let's say they wanted a copy of a 1 terabyte data set, NOAA had to send out 1 terabyte worth of data to that user. But if 1,000 users wanted to all use that same 1 terabyte data set, NOAA then had to send out 1,000 copies, which ends up being 1,000 terabytes of that same data set. What's nice about BigQuery is that when you make this available in read-only, you don't have to worry about scaling the bandwidth to meet that 1,000-person demand. The user pays for the query costs that they incur. So the project that's the billing account behind the project that accesses your data is charged for that query. So if you make your data public and someone you've never heard of before comes in and queries it, you don't have to pay for their access. You've only paid for the storage, and they're paying for their access and their analysis. So I just want to give a kind of high-level overview of the public data sets we have in the program. If anybody sees their favorite data set on here, let me know. That's a like thing that only works in audiences that are really passionate about seeing their favorite data sets, which I love because that's this group. If you see your favorite data set missing, shoot me a note, and I'd love to talk and learn more about what the use cases are and how we might be able to support. This is a like pretty generic snapshot of some of the data sets we have. This is out of our kind of catalog of data sets. You can see the link there in the bottom right. We call this GCP Marketplace. We host a whole ton of solutions in there, from pre-built virtual machines that have kind of all these different tools built into them. But this is also where we store our listing of the public data sets. You can see there's a really diverse offering here from NHTSA traffic fatality data when we were supporting them on their Solving for Safety challenge. You can see Nextrad level 2 kind of radar imagery from NOAA. You can see blockchain data from some of the most popular cryptocurrencies in the world. Kind of solar data for how much sun we expect your roof to see at a given kind of date and time in the year. And we even have Major League Baseball pitch-by-pitch data. So an offering of pretty diverse data sets that we're pretty excited about. And in particular, we find that our weather and climate data sets are really popular. And the reason for that being that users understand what temperature means. I can promise you that everyone in Pittsburgh knows what a 0-degree temperature means after this week. And I can really promise you that everyone in Chicago knows what that means too, assuming they got as warm as 0 degrees. So, what we find is that users from a really broad range of industries, from retail, from hospitality, all the way over to climatology and meteorology, find use cases for these data sets. In fact, weather and climate data sets from NOAA were 3 of the 10 most heavily used data sets, and we measure that by the terabytes of data scanned. I'm estimating that those 3 data sets, are maybe a couple gigabytes in size, maybe 10 if I'm really rounding up. We saw more than a petabyte of data scanned out of those data sets. From my experience at NOAA, we found that that's anywhere between kind of 30 and 300 times more data served out of here than NOAA serves out of there. It's tough to do the kind of one-to-one comparison, as they're just very different systems. But they're really popular, and we're finding, and NOAA's finding that we're helping amplify kind of that accessibility for users without the taxpayer or the researcher having to pay for that. Weather and climate data sets were also our most popular data set in terms of the average daily users, and we're 2 of our 6 most frequently used data sets. So that's daily average queries per day. Yeah, there's a little bit, I'll freely admit, there's a little bit of cherry picking going on in the sample size, right? Like, it's 2 of 6 of our most frequently used data sets. It's also 2 of 7, or else I would have said 3 of 7. But I think that this really clearly illustrates that, we're helping NOAA meet this kind of level of demand that existed long before we kind of started working with them. But, helping them kind of clear some of these barriers without having to scale out kind of their resources to meet this excess demand.
May I ask a question, or are we waiting until the end?
No, please do. In fact, I'm going to take the opportunity to take a drink while you're asking.
Okay, perfect. Thank you. So my name is Florence Hudson, and I work with all the hubs. And I also work for the NSF Cybersecurity Center of Excellence at Indiana University, and I lead a program called TTP, which is Cybersecurity Research Transition to Practice. So as I'm working with the cybersecurity researchers, some of them are saying, like one of them in particular at RIT in Rochester Institute of Technology said, I needed intrusion alert data to test my machine learning algorithms for cybersecurity. And so I'm kind of on the hunt for data sets like this, or like when I work with smart grid guys, everybody wants, PMU data, synchrophaser data. And a lot of this stuff is very, confidential, DOD, DO this, DO that. So, it's not readily available. But do you have or expect you might have data sets like this, which are non-confidential, that can be public data sets that, I'm thinking I would send this link. I was just looking at it and I saw there were some data sets there. There was like a, this probably isn't what I need, but VM series next gen firewall bundle 2 as an example, right? It says the word firewall. I'm like, oh, maybe they have some security data. So I'm thinking that maybe I would send this to some of the researchers who are asking me for data sets and say, do you see anything that might be useful? Or if you don't, what do you think would? Is that like a good idea or a bad idea?
It's neither a good idea nor a bad idea. It's a fantastic idea. I love it. No, and I have a little bit of background in the security field. I kind of did some of that before I went to NOAA, and I've still got some friends in the field. I'd love to reach out to them and see that. And I think that's one of the things we're seeing as a really popular use case for data sets is training machine learning models in general, because you just need a lot of data to do that. And no one has, most people don't have a lot of disk space just kind of laying around to test kind of ideas with. And that's, I think, a really awesome use case for public data sets. Yeah, my email's on the first slide. I'd be happy to go back to it later. And
I didn't write it down. That would be great if you could, and I'll send you an email, and I'll hook you up with this guy who's looking for intrusion alert data.
That'd be awesome. Carl, can we share that out, kind of share my contact information after the meeting?
Yes, we can do that.
Great. Yeah, so I'll get with Carl and we'll kind of send out an email with some of that contact information in there, and I'd love to learn more about that.
Yeah, and I'd love to chat with you, because the other thing that I found through one of these researchers is there's actually a conference called CAMLIS, Conference on Applied Machine Learning for Information Security. And as you know, if the machine's learning, there's data involved, right? So it could be, it's on my list to reach out to more of the people who present there. So we could create something rather interesting that could really support some of this AI machine learning for cybersecurity research going on.
Yeah, that'd be a lot of fun. I'd love to follow up with you about that.
Thank you so much.
Yeah, of course. So these are kind of some of our very recently added unstructured data sets. And they're all data sets I'm really excited about, despite the fact that I clearly forgot to replace the national water model picture over here on the right with something a little less grainy. So what you're seeing over here on the far left is the HER. It's the high resolution rapid refresh model. I'm gonna butcher the details here, but I'm gonna try my best. I believe it's a 2.5 kilometer resolution, high frequency weather model kind of over the continental United States. And in fact, we just started bringing this on, and I think that there's some really, really cool use cases for this in kind of the private weather enterprise, but also, of course, in the research space as well. You see this like really nice, beautiful picture in the middle of planet Earth. This is from NOAA's GOES-17 satellite in cooperation with NASA. NOAA launched GOES-16 and 17 within the last few years to replace kind of their previous generation of geo-orbiting satellites. So GOES-16 now sits over the eastern half of the US, kind of focused on the eastern coast and the Atlantic Basin, whereas GOES-17 is now over the western half of the US. We have both GOES-16 and 17 data on our platform, including the geostationary lightning mapper, which is really, really cool. It gives you, kind of detailed lightning strike information that is the first time kind of this kind of instrument's flown on a geostationary satellite. On the far right, as I alluded to earlier, is representation of the national water model. This is 2.5 million points of kind of continuous stream flow, soil moisture, snowpack data over the continental United States as well. So these are all the, we've talked a lot about BigQuery, and we'll talk a lot about how we can use BigQuery to work with some of these data sets in a minute. But these are some of the data sets that we're hosting in Google Cloud Storage that have some really, really great scientific applications as well. Okay, so you've listened to me drone on for quite a long time. I appreciate that. If you've kind of taken the headset off and walked away and gotten done something more productive, I don't know the difference. You still get credit for it. But so I think this is the fun part. I've got a handful of demonstrations here, and we'll kind of go from what I think being easiest to like most challenging or like most advanced level. Don't worry, you're all going to leave and you're all going to be experts in this, and you will be able to wow all your friends, colleagues, family, and maybe even people you don't like. So let's start with SQL, and I'm assuming that most people here, if not everyone on the call, are familiar with SQL. But if not, I want to start from a baseline just to make sure that we're all on the same page of what I mean when I say this. So SQL's been around since 1976, I think. One of my coworkers is going to give me a hard time if I got that wrong. But and kind of the real basic premise of SQL is the select from statement. So select and say what columns or what variables do I want, from what table am I selecting those variables from. So this is kind of the basics of what you need in SQL and in BigQuery to access and to start working with data. Okay, so you've mastered the select from statement, and you want to do something a little more advanced. You say, okay, well, this is really great, but what about data where I want it to meet a certain condition? So that's where you would add a where statement that says, you can give it, say, well, where these kind of columns that you have in your select statement meet these given parameters, right? Okay, so now you've stepped up to the where statement. You're able to say, okay, I want these data, but only when within a certain time period. But boy, I'd love to see them in a certain order. I'd love to aggregate them in a certain manner. So that's where you bring in your group by or order by statements. Order by allows you to say either ascending or descending order for a given variable. Group by would say, if you had some kind of aggregative function, some kind of a sum or an average, what would you be averaging, and then how are you grouping them in the results? And let's say you want to get real fancy and you want to go with a join statement. So this is where you would pull in data from 2 or 3 different tables. You'd bring them all together on a common key, some kind of common identifier that's unique for each row. And you could still do a lot of these, you can still do all these other statements that we talked about beforehand. Okay, so with that out of the way, we now have a clean baseline of SQL. And the first thing we're going to do is we're going to figure out what are the most famous trees in San Francisco. Because I know everyone woke up this morning and was like, this has really been bugging me. What are the most famous trees in San Francisco? Good news, we have an answer for you. How do we do that? Well, we're hosting 2 data sets through a partnership with the city of San Francisco. One of them being their tree census. They come around, they count all the trees in the city every year. The other being their film location data. Where were TV shows or movies filmed in the city? And we said, hey, wouldn't it be cool if we found all the trees in an address that matched an address of the address of the filming locations? And I said we're going to start from easy to hard. And why do I consider this to be the easy one? Because we already wrote the query for you. You can go to the film locations page on GCP Marketplace we pointed to earlier. You can click on the link. It'll load this query for you, and you can run it, and you can learn what the most famous trees are in San Francisco. So, that's kind of one of these things that we've done on Marketplace to help people get started, is providing these sample queries and allowing users to click through and to run these queries. And the idea being, it gets you a good start on the data set. It gives you a place to start, and you can kind of play out from there. So, okay, so what's next, right? So that's kind of the simplest version of this. So here's something I think is a little more advanced. So what we're doing here is we're taking hurricane data from the, no YouTube, I don't want to see more videos like this. We're taking hurricane data from NOAA's IB tracks, which is kind of the international community coming together and saying, we agree that this cyclone, this hurricane, or this this typhoon was in this given place at this given time. It apparently is shockingly difficult relative to how easy it sounds. So we've taken these fields, we've pulled out 3 key fields. So isometric time, the distance to land, and the center point of the hurricane by bringing together the latitude and the longitude in one single field. And for this particular instance, you can see that we're only looking at Hurricane Maria from the 2017 season. So you can see here, it's a little blurry. I apologize. I have no logical explanation for why, but I'll shrink it down and I'll share some of these videos out as well. And so what you're seeing here is a great example of how you can subset data in BigQuery and get just the observations you're looking for. So in this case, just Hurricane Maria, but the 2017 Hurricane Maria. So we've gone in and we subsetted this, and I cheated a little bit. The query was actually cached ahead of time. That's why it only took 0.03 of a second to run. I had recently loaded it. But I think one of the cool things that BigQuery can do is connecting out to Data Studio. This is Google's data visualization platform, and it allows you to kind of connect out and visualize this data very quickly. What I'm doing here is I'm just going in and instead of saying that the hurricane center point was text, we're just changing it to latitude, longitude, so that BigQuery interprets this data properly. And then with a few clicks, I went out and I kind of drag in this new observation, and we visualized the path of this hurricane very quickly. You can see this is the path that the hurricane took, and the shading is kind of done by distance to land, the sum of the distance to land here. So you can kind of drill down and see some of these individual points. Obviously, there's a lot of overlap here. So you can drill down and see the individual parameters for a given particular point you might want to look at. So I think this is a really cool way to go from kind of having data to having visualization really quickly. And the nice part about Data Studio is it's entirely free, and it is super easy to share. It's entirely web-based. All you have to do is send someone a link to your visualization. Once they have the link, they will be able to kind of view and interact with this kind of visualization without having to download any other additional software, any other additional tools like that. I love Data Studio. I don't say that because I work for Google. It doesn't hurt, but I do love Data Studio, mostly because I am a self-described data visualization enthusiast. I even have a favorite data visualization professor, but we can move on from that before I embarrass myself more. Okay, so I think this is kind of the intermediate step, right? Of we found the data set we're looking for, we've subsetted it to find just the data we want, and then we went out and visualized it. And that's a really important part of the scientific process, especially for those of us like myself that are really visual people. But what if I want to do something even more kind of advanced than that, right? And so let's talk about, we talked a lot about Go16 data or GCS data sets, kind of unstructured data in Google Cloud. So let's take a look at that and how you would discover those data sets. I'm going to go out to a random search browser. I'm just going to pick Google. I don't know why I landed there. And you can see kind of one of the first search results is this marketplace page we've talked a little bit about. And here we'll load the marketplace page for Go16. You can see in here we have a description of the data set. We have some links out to other data and to kind of some of the tools to work with it. And if you click on this link down here, it'll take you to the bucket that has the raw data in it, which is the raw netcdf files as they're produced by NOAA, which is great, except if you don't know exactly what data set you want to use, if you don't know exactly what subset of the data you want to look for. So if you have the naming convention of the file memorized, if you have kind of some of these other like very particular things memorized, and you're willing to search through the bucket, by all means, don't let me stop you. But I think there's an easier way to do it. And so if we go back, I'll go back just a little bit here, and you can see as we go through the marketplace page, I'll click on the big blue button at the top because that's what we want you to click on. That's why we put it there. And you can see we're loading a metadata index of the Go16 data. And what we've done is we're parsing out the metadata in the self-described netcdf files, and we're putting it in BigQuery to allow you to search and kind of dig through. And you can see a preview of the data here. And one of the exciting things is it gives you can see at the very end, it gives you the link to the data set as it exists on our site on Google Cloud. So you can go in, much like we did with the Hurricane Maria data, you can subset by the points that make up the corners of each bounding box that contain the image. You can subset by time, you can subset by kind of the channel of the data set you want to look at, and it'll give you a list of the files that match that result. So you can go in, you can subset this data in BigQuery, and then you can grab these file names and you can begin to create these really cool images, right? And there's the most popular way that I've seen for people do this, and I think the way we've done it for a very long time, is to take this data and manually download it to your local computer. And if it ain't broke, don't fix it, right? But I think it might be broke, and here's why. Okay, so we've gone in, and I'm gonna subset the data to include, this is 1 hour's worth of files from GOES 16, just from the level 1B products. As I scroll down here, you can kind of see, again, I cheated, it was cached. That's why the results were so fast. But you can see that, you get the individual file name. Now, what you're not seeing is that there are about 100 files that come up in this result. And this is just for 1 hour's worth of data. So if you wanted to visualize all of Hurricane Maria, for instance, you're looking at days worth of data, yes, over given points, but you're looking for a much higher level, a much higher volume of data. And so we could take this out, we could go to our terminal, and we could use the GSUtil SDK to download these data directly to our computer, and it would work. You would get the data on there, you wouldn't be charged for it, and this is all well and great. But it takes a while, especially if you're downloading 100 files, because it has to cover the public internet. There are a lot of points between whatever data center from Google you're pulling data out to your on-site internet. If you're working from home, like I am today because I don't like being cold, then you have to compete with your family member streaming Netflix or Hulu or whatever. You have to compete with your internet service provider maybe not having a great day. And it can take a while, right? So this is a way to do it, but I think there's a faster way to do it. And that is manually downloading the data into a VM. And so this works. This is a very similar process. We'll go in, we'll subset the data again. Again, I cheated. It was cached ahead of time, but this result comes back in a few seconds. We can copy the file name out, and we could put it in a VM in Google Cloud. I would click over to my console. I would click over to kind of the part of the web UI that allows me to launch a new VM. I would create an instance. I really just need kind of the basic parameters. I'm going to enable some of these APIs to allow me to download this data. I'm going to tick a few other settings, and I'm going to create a VM. Now, the magic kind of behind the screen, the cooking show magic, is that it takes about a minute to spin up or to create one of these VMs from thin air. But no one wants to watch, if you're watching a Martha Stewart cooking show, no one wants to watch the pie sitting in the oven for an hour. And that's why Martha Stewart magically pulls out another copy of another pie from underneath the counter. So if you see here, you'll see that I magically pull out my VM from underneath the counter. So about a minute later, I can come in and I would use the exact same command I used on my terminal. The benefit here being that the Cloud SDK is already preloaded on all these VMs. And I would download the data again. And it's a little faster. And it's more performant. You can shut down this VM when you're done. You're not charged for the VM. You're charged for the storage space behind the VM, but that's very cheap. And you're probably incurring very little cost to do your analysis. But that's kind of a lot of work, right? Of copying the file names over, and there's a more programmatic way to do it, but copying those file names over, spinning up this VM, having to remember to shut down your VM, and it's kind of slow and it kind of takes some time. Well, what if I told you there was an even faster way to do it? Wouldn't it be nice if we could automatically create a bunch of VMs, run some code, and then have them shut themselves down? And wouldn't it be nice if each of these steps kind of auto-scaled themselves, much like BigQuery does? You kind of pull in more resources when you need them, and you turn off those resources when you don't. Well, that's exactly what Dataflow does. And this is where I've invited Murphy to join the live part of our demo. As I'll pull this up now, I'll pull up this link. For those of you that haven't, that don't know, one of my colleagues' name, Lack, as he goes by, is a brilliant kind of machine learning expert within Google who's done a ton of work in the earth science space, including processing satellite weather data in real time using BigQuery. So I'll kind of scroll down here. We've already looked at a lot of these steps actually, and I have taken credit for them. Please don't tell Lack. He does know, but it doesn't hurt to not remind him. And so we have kind of these steps in here, and he goes through, if you wanted to plot a step-by-step image of Hurricane Maria as it was captured by Ghost 16, you could do that using Python, using the Pyre sample Python package. And he includes the code here on GitHub for it. But what if, instead of having to spin up the VM manually, he talks about this a little bit in the blog post, and instead of having to kind of pre-configure these VMs, what if every time a new image came in, you could automatically stand up the VMs that you need to process and add to this image instead of having to take the time to create one JPEG image at a time and kind of string them together? What if this kind of all happened in the background? And that's the benefit of Cloud Data Flow, of allowing you to kind of connect into these data sets and using them in a more repeatable process. So I don't have time, unfortunately, to go through all of this. I thought you guys would probably enjoy the other demos more. In retrospect, I may have been wrong. But so the code's available here on GitHub. When we talk about, it goes through kind of all these steps that we walked through today of pulling the relevant timestamps and locations from BigQuery, finding the corresponding file names out of this BigQuery search, which you see right here, and then running some Python code to process these and create this image. And that really goes back to kind of the core of what we talked about at the very beginning here, that if you could go from having to run all these steps of the quote unquote, the scientific process, as I joked earlier, if you could go from having to run all those steps to just doing your analysis and just visualizing your analysis and let us take care of the rest of it on the back end, I think that helps everyone kind of get where they want to be and get to the fun part of this. I mentioned earlier, I'll share out my contact information through an email with Carl. I'll be sure to include a link to this blog, and I'll be sure to include a link to this GitHub page as well. It is linked throughout the post, but I think it'll just be easier to have it right in front of you. So with that is all I have. We have about 10 minutes left. I'm more than happy to take some questions. If we run out of time, of course, I'm also more than happy to take those over email as well.
Great, thanks, Shane. I'll go ahead and turn things over to questions and see where we go, and we can hang out here. I mean, it's Friday afternoon, so I can hang out for a few more minutes if we need to go past the hour. So, with that, anybody have any questions, comments, or other?
I guess this is Steve, and I'd be interested in what the folks at the National Data Hubs think, how they could best benefit from a resource such as this, and what kind of data sets that you might have that you think would benefit from being in this environment.
Hi, Steve. This is Leah Shanley, the South Hub Executive Director. I want to thank you and Shane both for presenting to our group today. And I'm so glad we met at that conference in California earlier this year. We've got a couple of the executive directors on the line. I saw Melissa Cragen is on, and I believe Meredith Lee, so Midwest Hub and West Hub. Perhaps they'd like to chime in first before some of the other folks jump in.
Sure. Thanks, Leah. This is Meredith. I can definitely say that we have already benefited from partnerships and collaborations with Google Cloud and all of the different public data sets that we work together to put on that nice snapshot that Shane showed from the Department of Transportation and NHTSA to, Amy Unruh from Google in Seattle actually flew out to a hackathon in the Midwest and was mentoring and serving as a chair topically for some of those efforts. So it's been really great so far, and actually to build upon Steve's question and to look at sort of future collaborations, I wanted to ask Shane and any other Google folks on the line, about that snapshot of all the logos that you showed at the very beginning, and apologize if you already mentioned this because I dropped off due to signal for a little bit. But I see several federal agencies there and a couple of cities, looks like New York City a couple of times. Could you maybe comment on potential future opportunities or things you've seen where we might be able to help fill in some gaps at a regional scale? Fully knowing that we did a national great effort before, but knowing also that we are regional innovation hubs.
Yeah, and so I think we've kind of focused initially on these national level data sets. One, because you know, they tend to be like really broadly useful, right? Like they kind of tend to give you at least a good map of like the entire country, right? We've onboarded a handful of city data sets. You know, frankly, we found that it tends to be hit or miss on some of the usage for these. And, you know, we don't have infinite resources. And so, you know, we tend to focus our efforts where we can have the most positive impact. You know, that being said, you know, we recognize that there are also gaps there too. And we'd love to work with you guys to help fill some of those in. And I'd love to hear, obviously in a longer forum than the next few minutes, kind of what that looks like and how we can help work with you guys on that. I really appreciate you calling out Amy because she's awesome. I love working with Amy. She does really, really amazing stuff. And I almost forgot to mention her. So thank you for calling out her effort. And Meredith, I'd also love to talk to you more about bringing in more of the NHTSA data and how we can work with you on that as well. So I'll, if you don't mind following up with me after this, I'd love to kind of continue that conversation.
Absolutely. We're looking forward to phase 2. And given your self-professed enthusiasm for data visualization, I think it's a great match moving forward. And the sandbox is super exciting. I think that's going to go a long way in showing that early value proposition for some of the city and regional and federal connections.
Yeah, we're really excited about that.
This is Steve. I can't so much comment on the regional data sets, but I can just give you a little glimpse of what I've been doing, and that's been working on chemical biological data. So I've been working to get PubChem loaded with NIH through the EPA, Environmental Protection Agency. They have a, it's called DSS Tox database, part of the ACTOR data sets. So we're getting all the toxicology data associated with molecular content. We've already got the Chembl database from the EBI, European Institute of Bioinformatics. Of course, we have all the Sure Chembl data available, which is the molecular content from patents. So basically, most of the molecules that have been patented. And we also have, we have the Orange Book data from the FDA, and I'm working with the Genus to try to get that updated, which would be like an international or global dictionary, you might say, or encyclopedia of drugs available globally. And we're also getting all the GWAS data, which is the genetic data. So we're working to get all that data loaded in as well. We hope to have an announcement in August, and at that time, we'll be presenting a lot of the scientific data sets that I've personally been focused on working with partners, and as well as some new tools such as KNIME, so you can do workflow data management that'll hook up directly with BigQuery and allow people to use other tools such as KNIME, KNIME, and other data workflow sets. So if anybody has interest in molecular or biological data, drugs, diseases, things of this type, then please feel free to reach out to me, and I'll be sure to try to work with you on that.
Sounds good. So I know we're reaching the top of the hour. So I just want to let everybody who needs to run off to the next meeting go ahead and do that. But I wanted to thank Shane and folks for joining us today. And I'll stick around here if others want to have discussions about paths forward or other pieces. And the only other thing I wanted to say is that we are swapping around, I think, order. I don't know if this was mentioned earlier, swapping around order of the March talk. So we will have a talk in March about HydroShare, if I remember right now. So please join us for the HydroShare one in a month, and we will continue to promote that on the usual channels and let everybody know what's going on.
Now, this is Leah. Before Melissa drops off, it would be good to maybe have her kind of chime in. And
sorry, Leah, you're really quiet.
I have laryngitis. So.
Okay, that explains it, because normally you aren't.
Before Melissa drops off, she'd jump in, but Shane, would you be willing to get a call with the executive directors separately to have more time to talk?
Thanks, Leah. I didn't say anything because I would need to have another conversation with Shane. So I was going to reach out to him separately so I can get a handle around the priority areas for the hub for our hub regionally going forward and think about that. So thank you.
Yeah, sounds good. Looking forward to hearing from you.
Cheers.
And Shane, I want to thank you very much. You've done a great job in bringing everybody up to speed on this. It was really nice. Thank you very much. Yeah,
well, thank you. I really appreciate the opportunity to speak today. I actually am one of those people that has to kind of run to the next meeting, but like I said, I'm happy to share my contact information with Carl, and please feel free to reach out to me. I'd love to kind of continue the conversation.
Well, thanks again, Shane. And I won't rub it in that if you multiply your temperature by 3, we're still warmer than that here in Austin. So,
you know what? I wouldn't wish this on anyone. I'm glad you guys can feel your feet. We were in the sweet spot this morning where it was warm enough to hold moisture in the air to snow, but still cold enough that the rock salt didn't melt it off the road. So,
very good.
Yeah.
Very good.
So,
all right. Well, with that, thanks everybody for coming, and happy weekend, and we will get together again in March.
This was great. Thank you very much. And Shane, I look forward to following up with you.
Great. Thank you very much.
Thank you, Leah.
Thanks.
Thank you, Leah, for putting this together as well.
Yeah, thank you, Leah. Thank you, Carl. It was great.
Bye.
Bye.
Thanks all.